Hi, welcome to this lesson on calculus. What is a limit? Let's have a look at using a limit, question 3. So when you evaluate the following limits, if f of x equals the square root of x, then find the limit as x approaches 4 of f of x. So when we see functions like this, so this is a surd function because of the square root. If we haven't seen what this looks like in general, we can always get a general shape of the function by plotting some points. So we'll do a table method here. So my x and f of x, because the goal is to be able to just get a nice sketch of what this function looks like. Okay, well, first of all, can you see my domain of my function f has to be the set of all real numbers such that x must be greater than or equal to 0. So in interval notation, that is 0 to infinity, or in inequality notation, that means x greater than or equals to 0. All right, so those are the three different ways we can write the same thing, that the domain of the function f, because when we take the square root of negative numbers, we get imaginary numbers, and we're only dealing with the real numbers right now. Okay, so for example, if I take 0, then the square root of 0 is just 0. So I get a coordinate 0, 0. What about 1? Well, the square root of 1 is just 1. So at 1, I get 1. Now, I'm going to be smart and pick 4 because the square root of 4 is a perfect square number there, so the square root of 4 is 2. Right? This is positive square roots. That's, if there's no sign in front of that surd, then it's understood to be positive square root x. All right, so now at x equals 4, the y value is 2. So you can see this function is growing pretty slowly, 4 and 2. And we can do the same one. If we do 9, we'll get 9 and 3. All right, square root of 9 is 3. So if I plot the points and connect them, the curve it's going to go towards positive infinity as we keep going on, because if we try to do square root of infinity, well, we can't do that, but we know as we get square root of larger numbers, the numbers are increasing in size. So let's go ahead and put that curve together. So that looks something like this. Okay, so here we want the limit as x approaches 4. So first of all, the limit as x approaches 4 from the left. So that's the notation of f of x. So as we go from the left, can you see the y values are approaching 2? And then similarly, if you take the limit as x approaches 4 from the right, can you see your y values are approaching 2 as well from the right? So that's the limit as x approaches 4 from the right. So therefore, since the left and right limits agree with each other, the limit as x approaches 4 of f of x is equal to 2. All right, and that is that limit evaluated for this function. Awesome. I'll see you in the next one.